Alrighty. Well, let's see. So we don't get spoilers. We'll mute and turn video off for everyone. All right, here we go. I am still looking for a Jonathan Cranford with Nuvost, but if he shows up, great. If not, that's okay too. Anywho, so where are we at? We're at 32 people here. So we'd like to welcome everyone out to another UJUG meeting this month here in September. Hope everything's going well. People are healthy and well. Hope you've enjoyed the summer. And actually, no, sorry, we're in August, not September. I'm losing my months. Anyway, hope everyone's healthy and well and getting ready for school for any children that you still have at home. But let's see, Jason Lunt says he is not here. Jason, are you with Nuvost? If you are, let me know. And if you want to do the spiel, then feel free. If not, that's okay too. So let's go through and we will do the whole, what we've got going on. So tonight we have with us Ken Kousen, who is talking about functional programming in Java, Groovy, and Kotlin. So kind of a comparison and contrasting on how those different things work. And of course, we've got our wonderful sponsors here. We have Tech with us who will be speaking, and hopefully Nuvost will be showing up and they can do their spiel. If not, well then that's okay. Upcoming schedule. We have next month, Nathaniel Shuda is speaking on thinking architecturally. And then in October, we have Edson Yanaga talking about reactive programming and Quarkus. And then to finish off the year in November, we have Baruch from JFrog, who is talking about DevOps patterns and anti-patterns for continuous software updates. And I think that should launch us up into what we've got going on. So we've got Kate over here. We've got Jason as well. So let's see if we can bring Jason up in just a minute. And we've got Kate. So maybe toggle video. All right, here we go. Take it away, Kate.
Hi, everyone. I'm Kate Conroe. I'm with Tech Systems. I'm a recruiter there. Just hit my 4-year mark actually recently, which is kind of exciting. For those of you who don't know me, I recruit primarily in Java. Love the Java space. Love the Utah Java user group. I've been going almost every single time for the 4 years I've been at Tech Systems, and I think they just provide such phenomenal resources for you guys in the community. So those of you who do know me probably know that I am very prone to tell stories. I oftentimes, when I do these presentations, I'll get up and say, so the other day, so I was going to tell you, so the other day, I was talking to this engineer, and it was kind of funny, you know, a lot of the time people ask me like what it's like to be a recruiter. And I kind of joke sometimes and say, well, like not everybody is as nice as you. Well, this particular engineer that I was talking to was probably about the rudest person I think I've talked to in 4 years. Crazy, right? And the reason I bring this up is because I sat there and I thought to myself after I got off the phone with this guy, what happened to him? Like, what kind of terrible experience has he had with a recruiter that made him just be so angry with me? Because I don't think I'm like, you know, really inspire a lot of anger in people. But, you know, so I kept thinking about this and I was just like, wow, it must have been some really bad experiences for this guy. And so it kind of got me just thinking about generally, you know, what we do at Tech Systems to make sure that you guys are having a good experience. And so I wanted to talk about just kind of two little aspects of what we do with our training when we're training new recruiters to come in. And those are called kind of funny names. So there's voice of the customer, and there's what we call the hearts and clouds. And so the voice of the customer is, it's essentially an entire program that we have around listening to what you have to say. So we do surveys with our consultants where they can give us feedback on how we're doing, what we can do better. And then we also, when new recruiters start, you probably have had some of these calls if you've ever been a contractor with Tech Systems. They spend a lot of their time doing these voice of the customer calls, and they go and they call people who are currently on contract with us, and they say, you know, I really would like to know, what do you like about Tech Systems? What can we do better? You know, just generally getting that feedback so that we can continue to always make sure that we're giving the very best possible service. So the other thing, the hearts and the clouds, is it's essentially kind of a a program that we created that talks about the hearts are things that you guys like. So they're things like, you know, having continuous opportunities, seeing multiple opportunities, not being pushed to just go for like the one thing that we think that you should go for, and generally just being very, very supportive of you. The clouds part is, you can imagine, is kind of the opposite side of that. So it's the things that really frustrate our engineers or our technical people, and the things that they tell us, like, you know, being placed in a position and just totally forgotten about, not getting feedback, you know, the things that as, you know, somebody who's working in an engineering role can really frustrate you. And so I wanted to bring these up today because I want you to know just how utterly serious we are about your happiness. We really care. We really want to make sure that you're having a continuously good experience with tech systems the whole way. And if for some reason you're ever not, we really do want to hear that, because we want to make sure that that is a great experience. So I'll keep it short, but that's, you know, what I wanted to share with you guys today is just, you know, why I love working at tech systems so much is because I have this great opportunity to network with some of the coolest people. And the fact that I'm kind of like this touchy-feely person that really cares about everyone I work with, it's really encouraged, and it's something that goes along perfectly with our culture. So thanks so much for listening today, guys. Wish I could see you in person. That's the hardest part for me, is not getting to see your awesome faces and get to interact and take you guys to lunch. But I promise you, as soon as COVID is over, any of you who want, call me up and let's grab lunch.
Alrighty, great. Thanks, Kate. Appreciate it. And we've got Nuvost over here. So Jason, you are up and you're live. And then we'll kick off things as soon as you're done. Thanks. Unfortunately, we cannot hear you, Jason. Nope, it looks like you should be unmuted, but I've got no sound. we can try to read lips. Shall we try again next month? See if we can get you guys up next month, Jason. All right, sounds good. Cool, awesome. Thanks. No worries. All right, and I do have one other. Here we go. Share screen. All right, so our door prizes that we've got going on tonight, we have the typical 2 license of JetBrains IDE. That could be any of their IDEs, and then we also have a 1-year subscription for Agile Learner coming from Venkat. And Kate has also said that she will be anyone that's local. I know we do tend to have some people that are not local. Anyone that is local, Kate will be willing to do 12 cookies. So we've got some cookies coming from tech as well. I did not have that on here, but that is there. And you can see down at the bottom, we have a poll that should be visible now to enter you into the door prize drawing. So if you're interested, then click the yes, and we will do all of that at the end. So I think we are good. Oh, there is one other thing that that I want to mention, and if Don or Jonathan are here, if you wouldn't mind posting our YouTube link, that would be very helpful. What we're trying to do, we are trying to get enough subscribers. We need 1,000 subscribers, so it's going to take us a little while. But if we get enough subscribers, then we can actually get a vanity URL, and it'll be easier to find us on YouTube. We are streaming to YouTube as well. So you can find us there on YouTube, or you can find us here at Crowdcast, either way. So I think without any further ado, we will bring Ken up. And Ken, you should be live. So we will turn the time over to you. Jonathan, thank you so much for putting that in the chat. One other quick little housekeeping item that I forgot to mention. If you have questions while Ken is speaking, feel free to ask them in chat, and then I will post them over to the Ask a Question, or put them in Ask a Question, and people can upvote as well. Ken, do you want to take those as they come, or do you want me to save those until the end?
No, I'll take them as they come. I can keep an eye on that. And if it's a question that takes a bigger or longer answer, then I'll just answer it at the end. I'll mention that I'll defer that one. But if it's something I can answer on the fly, I will.
Perfect. Alrighty. So we will turn the time over to you. Thank you so much for coming here with us and teaching us a little bit more about functional programming.
Well, thank you for the kind invitation. I'm very glad to be here, so to speak. I'm actually based in Connecticut, for what it's worth. So I'm on the East Coast of the U.S. If you know roughly where New York City is and roughly where Boston is, I'm about halfway in the middle. A little bit more on the Boston side. So think Red Sox, not Yankees, or Patriots, not Giants. Basically that idea. So I want to talk to you about functional programming. One thing I'd want to mention, though, in your upcoming schedule, I saw that you have Nate Shuda coming next month to talk about thinking architecturally. Try not to miss that. That's an outstanding presentation. He does a brilliant job with that. I'm also a speaker on the No Fluff Just Stuff tour. That's how I've had a chance to visit Salt Lake City a couple of times. So is Nate, of course. And I noticed in November, I think you said you've got Baruch Sadegorski coming in as well. Baruch is my co-host on the Groovy podcast as well. So please give him a hard time on my behalf. I mean, I'll try to do it in anticipation, but if you're the ones that'll be there. So please do whatever you can to give him a hard time if possible.
Sounds good. You can also come in and give him a hard time in the comments in November.
Yeah,
as
but
well.
if it comes from me, he knows he's expecting that. So
fair enough.
I think we're going to do a Groovy podcast next week, by the way, but that's a whole different issue. Okay, let me share out my screen here. So here's the share screen button, and I will select the screen I'm on, actually. And rather than go to Inception, I'll slip over to here. Is that showing up? Because I can't see the myself right now.
Yep. It's all coming in clear.
Okay, for those who are interested, I am going to take these slides and I will extract a PDF out of them, and I'll email it to you after or to the organizers after the presentation is over. So that's coming. You're welcome to them. And I want to talk about all three languages, Groovy, Java, and Kotlin, and specifically where they have their functional programming capabilities. I just realized, actually, let's see if I can move this over to another screen here. There. Now I can actually see the, I can actually see the chat box. So if anything comes up in the chat, I should be able to see that as we go along.
Very good. Still coming in great.
Okay, good. Thank you for the verification. For the record, my name's Ken Cousin. It's cousin like the relative. It just doesn't look like it. So it's pronounced like the relative there. Those are the books that I've written in the past. The most recent one is that Kotlin Cookbook that was published back in December. The Modern Java Recipes one is about these functional features that I'm going to be talking about. And my first book was the Making Java Groovy one. So I have experience with all three of these languages. I've spent a lot of time on the JVM, I guess you should say. And there's some of the evidence to back that up. So at any rate, here's my email address, homepage, blog, Twitter handle. I'm like half the world at this point. I have a free weekly newsletter if you happen to be interested in it. But the other thing I do want to mention here is the GitHub repository for the source code that I'm going to be using. So let me actually paste that into the chat box there. So if I add anything during this talk, I will just push those changes to the repository. This is a demonstration of nothing else, that you can use all three languages in the same project and have them interact without a problem. So there's where all the code's going to be. Now, I should mention that I actually am a certified training partner for Kotlin from JetBrains. And I would do that for Groovy if there was such a program, and I would do it for Java if there was such a program, but so be it. Let me get rid of this little box at the bottom. There we go. Now, the thing is, all three of these languages are compiled. So we're not talking about JavaScript or anything, which is an interpreted language. They're all languages that compile to Java bytecodes. They're all so-called alternative languages on the JVM. So this makes integration between them very easy in general, because they're all using some of the same libraries. They can all work together in various ways. Now, I also want to say none of these are actually functional languages. They're all what technically you'd probably call an object-oriented language, but with functional features added to them. And the question, of course, that one of the things I'm going to be talking about is how many functional features, what functional programming features have been added to the various languages. Ultimately, if you really are going all out for functional programming, if the words category theory make you go, oh, cool, let's do that, then there's Haskell. And of course, Haskell on the JVM is actually another language called Frege, F-R-E-G-E, after a German mathematician. And that one really is Haskell syntax running right on the JVM. That's beyond the scope of what I'm going to be talking about. I'm going to talk about just Java and Groovy and Kotlin. Now, as I say, they are OO languages with functional features to them. Now, I know I don't really need to summarize anything about Java, but just for the record, Java just turned 25 this year, so that there was various celebrations and everything. And the spec, the Java language specification, is managed by Oracle, but of course there are many, many implementations of that spec. The one that is most well known these days is the OpenJDK project, which you can get through Adopt OpenJDK or various other ways, but there are many other implementations of it. I have experimented with 2 or 3 of them, and everything I'm doing works the same on all of them. But then again, all these implementations adhere to the spec, so that's fine. The functional features, such as they are, that were added to Java were added in version 1.8, which is about 4 years ago at this point. The current long-term support version is 11. Java now releases a new major version every 6 months, so every March and every September. We're coming up on the release of Java 15 a month from now, roughly. And those brief fixed 6-month releases are releases where Oracle expects you to upgrade after the new one comes out. I guess that's an awkward way of saying that when 15 comes out, as far as Oracle's concerned, 14 has no meaning anymore. That you should move to 15 as far as they're concerned. Now, because most companies are not interested in upgrading their JVM every 6 months, we have these LTS, these long-term support versions, which are guaranteed to be supported for a minimum of 3 years. So Java 8 or 1.8 was retroactively considered an LTS version. The current one is 11, and that's the one I'm going to use. Now, Kotlin and Groovy both run under Java 1.8, but they both, Kotlin can run on earlier versions. Groovy can run on earlier versions. Those are somewhat discouraged at this point. But asking people to run on Java 1.8 is not, these days, not a high bar in general. That's a reasonable request. But they work on 11 and above. Now, of course, as I mentioned, the current version of Java is 14. I've run everything on 14 and it all works, but I don't expect anybody's going to be working with that. And again, 15 will be out in a couple of months, and then, or 1 month, and then 16 in March, and then 17 will be the next long-term support version. That'll be out a year from September. Groovy was an open source project and eventually was converted into a top-level project at Apache. So Groovy is an Apache project, and that it uses the Apache governance mechanisms and the support and everything. So their releases and everything go through the Apache structure that they've defined over there. And its biggest selling point, frankly, is it's quite mature. Groovy was invented roughly 2003. So that's been around for, well, about 17 years now. And its syntax is very similar to Java, very easy for Java developers to learn. And in fact, you can take most Java classes and rename them as .groovy, and they'll probably compile under Groovy. They wouldn't be idiomatic, but the syntax is sufficiently similar that it's very likely they'll work fine. One of the ramifications of this is that there aren't a lot of Groovy success stories, because every Groovy success story is probably a Java success story. In fact, most usages of Groovy are in Java projects where they added Groovy to do the things that Java doesn't do very well. So Groovy, it makes a lot of things simpler, and we'll see some of that. And Java, when it moved to Java 8, added its own functional features. But here's the thing: if you're in Groovy and you decide you want to do something that Java does, you can just write the Java code, because Groovy will rest on the Java SDK, the Java libraries. Any library that comes out in the Java world can be used in Groovy directly. And it's actually a nice way to experiment with new libraries. The current version, they changed the major version to 3.0 earlier this year, and that allowed them to use all of the syntax for lambda expressions and method references and everything that was added to Java back in Java 1.8. So up until then, Groovy had its own syntax for closures, as they're called in Groovy. but now you can use the Java lambda syntax and method references and static and default methods and interfaces. All those things now work in Groovy as well. Groovy was given a big boost when Grails was hot. Grails was basically a web framework based on Spring and Hibernate. Grails is still quite active, incidentally. It's still a very good project. They're on Grails 4 at this point and still used in a lot of places. The Spock testing framework is one of the more popular testing frameworks around. Gradle, the build tool, was an offshoot of Groovy. It was created by the Groovy people, although I must admit that the code inside Gradle is almost completely Java at this point, but Java is not good for creating what they call DSLs, domain-specific languages. It doesn't have a meta-object protocol, as they say, and Groovy is very good for that, and interestingly enough, so does Kotlin. So in fact, Gradle has a Groovy DSL and a Kotlin DSL both. Rat-Pack is a microservice framework. Probably the most popular microservice framework in the Groovy world is Micronaut, but Micronaut also supports Java code and Kotlin, so it supports all three, interestingly enough. Jeb is a way of doing functional testing by driving. It's basically browser automation. Griffin is a desktop framework for Groovy, that sort of thing. Now, Kotlin comes from JetBrains. Since you're giving away a license, I should at least mention that. Their homepage is at kotlinlang.org. Kotlin does compile to Java, but it also has what they call Kotlin JS, which means it can generate JavaScript instead. And they can do what they call multi-platform or native applications. And some people do that, and JetBrains really pushes that. I got to tell you that I'm sticking with the JVM here, that my experience with cross-platform toolkits is a little dicey, and I don't want to just use lowest common denominator stuff here, so I'm going to stick with the parts on the JVM itself. But if you look into Kotlin, you will see some subtle pressure where they'll be trying to push you to consider multi-platform development under that. So the thing that put really Kotlin on the map, even though it was already an active language, was when Google announced at Google I/O a few years ago that Kotlin was going to be the definitive language for Android development. Nowadays, if you do any development with the Android SDK, I don't mean one of the toolkits that generates Android, I mean actually using Android, then really the preferred language for everything is Kotlin. Google announced that when they develop new libraries for Android, they will develop them in Kotlin and maybe port them over to Java. So it really is driving the community in that direction. I think it's something like 70% of the top 100 apps under Android are now written in Kotlin. The other burst for Kotlin is that Gradle, again, I mentioned, has a Kotlin DSL. I should also mention, for those of us who are Java people and always were, the Spring framework, probably one of the most popular open source projects in all of Java, is very happy to work with both Groovy and Kotlin. You can go to the Spring initializer and create your app starting with either Groovy or Kotlin if you like to, and then take advantage of all their features. They have some Kotlin DSLs. They have some Groovy reactive things. It's very, very powerful stuff. But Kotlin is the youngest by far of all of these, so I expect there'll be changes over time. There'll be new features added as we go along. All right, so then looking at the functional features, Java, as you know, has 25 years of backward compatibility to think about. So what they decided to do is when they added the syntax for a lambda expression, they decided not to add a class called lambda or an interface called lambda. They added instead single abstract method interfaces. Of course, they've had interfaces from version 1, but if an interface has exactly one abstract method, then you can assign a lambda to that. And you can think of it, the lambda can be considered then as kind of the implementation of that single abstract method in the interface. And you can even kind of picture Java's compiler as generating some inner class that implements the interface and takes your lambda and uses that as the implementation of the single abstract method. Now, it's a lot more efficient than that. That's not actually how it works, but it's not a bad mental model. It's a decent way to think about how Java handles these things. Now, Java makes it so that you don't actually put in parameter types, believe it or not, in your lambda, because they are inferred from the context. The lambda is always assigned to a reference somewhere, whether it's an argument to a method or a constructor or a return type or assigned to a variable, and that variable is an interface type that interface has to be a functional interface, meaning it has a single abstract method, and then the signature of that single abstract method sets the parameter types. So this is all done at compile time. There's nothing dynamic here. It's all figured out at compile time and works very cleanly. So as one of the differences in Java between some of these other languages, Groovy and Kotlin, is that in a Java lambda expression, you can access local variables that are within the scope but outside the lambda, but you cannot modify them. They use the term final or effectively final for those variables. A final one, of course, would be declared final, but even if you don't use the keyword final, local variables are effectively final. As soon as you modify one of those variables inside a lambda, then the code will no longer compile. So this is a compromise, but it's the same compromise that was done when they added inner classes back in Java 1.5. Groovy, on the other hand, and Kotlin, interestingly enough, use what are called closures. And the difference between a lambda and a closure is probably, wars have started over less, okay? It's a dicey definition. There's no formal definition, but arguably the way it's supposed to work is a closure means that the expression is closed over the execution environment. In other words, the code in the lambda expression can access any variable within its scope, and some of those variables are declared outside its scope. Now, in the mathematical theory of functions, there's the notion of something called a pure function. A pure function is defined as a function that always returns the same output for the same inputs, meaning it doesn't depend on anything outside the function, and also has no side effects. Java, Groovy, Kotlin, none of those have any ways of enforcing that. But the term lambda expression is supposed to kind of generate that idea of a pure function in your head. That's the goal. That's what we're aiming for. But in Groovy, they're not lambdas, they're closures. And in fact, there's a class in Groovy called closure. It's groovy.lang.closure. And it's got a method called call, and you could assign variables to it and everything. I'll show that in a moment. So in Groovy, not only can you access local variables, you can modify them as well. So that's interesting, adds a layer of complexity, but it's still easier than understanding closures in JavaScript, which isn't really an object-oriented language. It's a language where you pass around functions, so it's close to the functional programming mechanism, but we don't have classes per se, and therefore sometimes it's hard to figure out what's in scope at any given moment. What's this variable pointing to is always a challenge in JavaScript. Java, Groovy, Kotlin, these are all strongly typed. There are classes. You'll know what instance has been made available and what variables are in scope inside that. Now, Groovy also has a delegate property inside the closure. And what that means is when you write code inside a closure that accesses a variable that it can't find in the scope. So if there is no local variable or even an attribute in scope, Groovy will look at the delegate for the closure. That'll be some object somewhere and say, I'll search in there for that delegate. And by manipulating the delegate property on a closure, that's kind of how you make these domain-specific languages in Groovy. You can change the delegates and thereby make Groovy do a lot of what you want. We'll look at that in Kotlin also. So again, in Groovy, these are closures. You can access local variables and modify them. Now in Kotlin, just to summarize that one, they actually use the term lambda expressions, and they look funny. So there's no class called closure or lambda. There's no interface. Instead, what they do is they write a particular syntax where you see parentheses, and in the parentheses, the input arguments are listed as data types, and then an arrow, and then the output type, and that's actually the type of the variable. So I'll show you that in a moment. So that's really different from the others, but they're still the same concept. And the syntax of the lambda expression itself is directly the same, almost exactly. I'm not going to say almost. It is exactly the one from Groovy. If you play with Kotlin, you'll find that Kotlin is really kind of a Frankenstein monster. They have taken features from lots of other languages and put them all together and stitched them together. And sometimes you can see where the seams are on some of these things. But it's they chose well. I mean, the things they've chosen all work together well and become very powerful. But it is interesting that if you know Groovy, if you know Scala, you see all these things in Kotlin. You go, oh yeah, I know that from here. I know that from there. And that's just interesting that that's the way they chose to solve the problem. A Kotlin, instead of having a delegate for these lambdas, has a receiver, but it's the same concept. It's the class that is searched when trying to resolve members, meaning attributes or methods inside the lambda expression. And again, that's partly used in how Kotlin can make a DSL as well. So they can access local variables, and not only access them, they can modify them, which means really these are closures. They just don't call them closures. So again, it's, you know, it's nice to know the concept, but the terminology is dicey in all of these. Now, to show you a few examples, here, of course, are the Java ones. So let me go to my code here. Now, this is the code that I mentioned earlier. It's the one called Java Groovy Kotlin. And I'll show you the Gradle build file. I have a Groovy plugin involved. And this is the Kotlin plugin for the JVM. And the Groovy plugin includes the Java plugin. So that involves all three languages. Here's my Groovy library. The Groovy library has actually been modularized so that I don't really need to use all. I could just pick the individual sections I want. But just to keep things simple, I added them all in, and there's the current version. Whereas Kotlin, you declare which Java version you're generating bytecodes for, and I'm using the JDK 8 version for the standard library. I have several other dependencies here. I've got Spock tests that come from Groovy. I've got JUnit 5, that's the JUnit Jupyter part. And in fact, all the tests that are for the Java code or the Kotlin code are written in JUnit 5. The ones for Groovy, I use Spock instead. I got to tell you that for the GitHub repository for my Kotlin Cookbook, for that book, in fact, I used JUnit 5 tests for everything, just implemented in Kotlin with their DSLs and everything. So it's nice and clean, easy to work with. I did throw in the Hamcrest matchers as well. I do have a little bit about coroutines, but that's pretty much everything. So now the first thing I was suggesting was this little Lambda demo. So let me bring that up. So again, this is just regular Java here. I have a list of strings, and we have, this would be the anonymous inner class implementation of a consumer. You create a consumer, it has an accept method. This is one of those functional interfaces that was added in Java 1.8. So when I do the for each method, which takes, sorry, I meant to mouse over that. The for each method takes a consumer as an argument, then you could implement one with an anonymous inner class. Of course, that kind of misses the point. Whereas I'd rather do it with a lambda expression. And if I say, oh, replace that with a lambda, then it would look like this. For each argument S, and I don't have a data type here, but the S is each string in the collection. That's the context here. Then I'll simply print it. And in fact, because all I'm doing is simply printing this, I can even replace that with a method reference. I must have added, oh yeah, I added a comment to not warn me about that. Let me comment that out. And now I can let IntelliJ go, yep, there's the method reference syntax. So I'm referencing a method called println on the system.out object. Each element of the collection is passed into the println method and printed directly. So I can go back to the Lambda version. If I put something in here to say the string is, now it no longer has a method reference version. The method reference version only works if the implementation is a single statement and I don't modify the argument in any way. Now, the alternate syntax is here is that I can expand this to make a body. So this is, now I can have multiple statements in here. If I was returning anything, I'd need the return keyword. I can say if I want that I want to see the parameter type, they use parentheses around it. And heck, I can even let IntelliJ say, yeah, let me see the anonymous inner class version, which is where I started with this. So you learn it by whichever syntax makes sense to you, and you can convert between them as you go. I'll show you the quick map filter reduce idea in Java. So map filter reduce here. I have a collection of strings again using arrays.asList. Now nowadays in Java 11, I could write list.of, but I didn't. And then here, for example, you see that what Java did is they added this stream method in order to add the map, filter, and reduce methods on top of that. So the stream method is a default method in collection. So it's a, let me magnify that. It's a method in collection called stream that converts the collection into a stream. A stream is an interface in Java. It produces the elements one by one from the source. It doesn't save them anywhere. It does not modify the source, which is important. And then it proceeds to work with the data until you hit a terminal operation. This map to int method says take each of the strings in here and invoke this function. The argument to map is a function, one element coming in, one coming out. I'm using a method reference to the length method, so this will convert each string into a length. I convert it to map to int to make an int stream, and an int stream, knowing that they're dealing with ints, has a sum method. So this basically is a method that will sum up the lengths of all the strings. And in fact, what I have here, by the way, is a test case written in Groovy. So this is a Groovy spec, if you will. They use the term specification in Spock. So it's traditional to end the name of the class with the word spec here. I instantiated this Java class. So this is a class written in Java. And here is a Spock test that just adds up all the lengths, and I expect that to be 20. Or if I just want the even length strings, that should be 12. If I want the odd length strings, that should be 8. I can also say, well, let me reference a method over here called isEven, and that's the Groovy syntax for a method reference. I can now replace that with the Java one if I want. This is a Groovy closure. We'll get into all that. And then this evens and odds is over here. What I did is I declared a couple of predicates as public attributes, and these are predicates, another one of those functional interfaces added by Java in version 1.8. So I can actually make those public interfaces, and what you'll see here, getting off by one error. I hope these are right. I'll have to check it. But at any rate, there's the sum with the filter where I explicitly say even. Here's a sum with a filter where I explicitly say odd, but here's a sum with an int predicate where I say apply whatever the predicate is. And in my test here, you'll see here's the one for evens, here's the one for odds. And down here, I'm using the int predicate one with the declared variables. So if I run all of these tests here, and I did run the Gradle build ahead of time, so they better all pass. That would be bad if they don't all pass. So it figures that it's taking time to start, which is annoying, but so be it. It should be working okay. Yeah, there we go. I don't know why it's the first time you do it. Sometimes it does. Well, it's not usually this slow, but okay. All right, there they all are. So you see all the tests did, in fact, pass. And I don't think I printed anything out on all that. So they're all good. I'm not sure what the startup time was. Yes. Yay. They always happen to be wrong. Notice, by the way, in Spock tests, you don't need an assert keyword or anything. You put a Boolean expression under expect, and all these Boolean expressions will be evaluated one by one. They'll all be checked against that. And in fact, the equals equals operator here, even though that makes sense for primitives, the equals equals operator in Groovy does operator overloading, and therefore it actually delegates to the dot equals method. So if I was working with a string class or a person class or what have you, if I have an equals method in there, then I can still use the equals equals operator. This is interesting because actually, Kotlin does the same thing. Now, here's a slightly more interesting one, a prime number checker. So let me open that up. So once again, this is the Java approach. And here is how I would write this code in Java 7. It's a brute force calculation. This is hardly optimized. I basically say if x is less than 2, I have an exception. If it's equal to 2, well, that's prime. And then what I need to do is take every number from 2 up to this limit here. Square root of the number plus, just basically square root of the number rounded up, plus 1 cast to an int. And I'm going to divide by each of those numbers on the way up. And if any of them divide evenly, then that's false. Otherwise, I'll return true. This sort of code that I absolutely have to test because the chances of off by 1 errors for me would be really high on that. But here's the functional approach. Here's an isPrime method that takes an int. Again, I've got the illegal argument exception idea. Again, I compute the limit. But notice how the functional features of Java can simplify the implementation of the loop and the if statement. I'm basically saying either x is 2, at which point I return true, or int stream has a range closed method, which will go from 2 up to and including the limit. Range is for 2 up to 1 minus the limit. Range closed goes up to the limit inclusive. And it'll take each number there, and I want to divide x by that number each time and see if it's 0. When I say divide, I mean modulus that number. And if none match, see, none match is a method on stream that will return true if none of the numbers divide evenly by that, and false if any of them fail to satisfy the predicate. So of course, as I say, I have to have a test for that. I just wouldn't believe it. So this again is a Spock test where I have my prime checker. Could I have skipped the x equals 2 test? I don't think so, because again, I don't have a condition for 2. So I explicitly checked for it. Yeah, I don't think this would work if I left out the 2 test, but easy enough for me to check, by the way. So I want to show you, I'm going to run the test, but first let me also show you the Groovy version of this guy. So here's the Groovy version. And now you see what the Groovy closures look like. So first of all, I don't see public or private. In Groovy, classes are assumed to be public unless you say otherwise. Methods are assumed to be public. Attributes are assumed to be private. So the defaults make sense in Groovy. Here I'm, again, throwing my exception, computing my limit, and that looks just like the Java code. Although, honestly, in Groovy, I don't need this cast, because Groovy, it will take a double or whatever I have here and assign it to an int and automatically do the cast for me. But just to be explicit about it, doesn't seem to hurt anything. One of the other things about Groovy is that in Groovy, you don't need an explicit return keyword because the last evaluated expression is returned automatically. Now, this is a Groovy range. The lower limit is 2 up to, then dot, dot, up to the upper limit, the one that was calculated. And that will do basically every number in the range. And find is your find first, basically. It says, give me the first value that satisfies this, and this is the closure. The little integer here is IntelliJ telling me what the data type of n is. That's not in the code itself. I could remove that hint if I wanted to. And then this will do the lambda. Notice that in Groovy closures, the braces go around the entire expression. So you still have an arrow, you still have default arguments, you still have the right-hand side, but now everything is in the braces. And if the right-hand side had multiple lines, that's fine. I don't have any special syntax for that. So again, here's the checker. So if I go to my spec here, this is a Spock test that will run all of these values one by one, and I'll check both that the Java is prime works and the one with Java 7, and the Groovy one as well. And of course, just on the off chance that these are just returning true, I'm also checking not prime as well. And I can also check that the is prime with a negative number up to 1 throws an illegal argument exception. So these are all Spock tests, and when I execute this, yeah, things are going to go a lot faster now. You can actually see over here, I don't know if this magnification is helping, but you can see the actual numbers being written out like this, along with the statements that I put inside there. So I'm able to check my Java code and my Groovy code with the Spock tests. I'm able to actually see the value written out in the build statement. I can use this left shift syntax to provide the elements one by one, or I could even use a range like this and write out whatever throws an illegal argument exception. All of this is part of the Spock framework, which is actually kind of neat. So these are Spock specifications with that little unroll. I think in Spock 2, I'm not even sure I need that unroll annotation anymore. It may be implied. Now, of course, the question that you were asking was, can I remove the 2 test here? And if I do that and just run my tests again, let's see if they fail. Again, it doesn't generally take this long on my machine to do this, but no, and of course the one that failed was 2. And by the way, this is a neat syntax that the Spock people came up with that shows you each individual element Oh, I could remove it if I drop the +1 after the square root. Really? Are you serious? And I could have simplified this. And by the way, of course, now I can take that out too. Okay, now I got to see. But this is why I write test cases, because I'm not an algorithms person. I talk to people about algorithms, and I just make sure I have a test case to verify. No, and that didn't work for 2 or 3, in fact. So I'll have to look into that. But let me go back to what we had. Let's just prove that it wasn't the int cast that was the issue there. But I think the key is I need to round up. That's the idea. And I think that's going to miss also. Yeah, that's still failing. So let me go back to what I had on that and the 2 check and everything. Okay, so at any rate, that's showing Groovy simplifying Java a bit. But I got to say, JUnit 5 with its parameterized tests makes up a lot of the gap here. You can run tests with a different set of data each time. But still, and you see that in Java, the prime number checker has gotten a lot simpler than it was in the Java 7 days if you use these functional features. Okay. Can eliminate even that. Tell you what, would you send me an email and I'll take a look at this afterwards so I'm not taking up your time for that. And that would be interesting. I'll skip the streams demo there and I'll just go on. So I showed you the group.
Ken,
question?
Just paste your GitHub repo and then people can send pull requests.
That's another thing. And I did paste the GitHub repo in the chat box. So yeah, if you want to send me a pull request, just make sure the test passed. then I'll be happy to merge that in, and that way I can even give you credit and everything. So yeah, absolutely, feel free. Okay, now Groovy has one issue that's kind of annoying, in functional features, I mean, and it's that Groovy got there before Java did, and they unfortunately didn't use the names we're expecting. Like in Java, the stream interface has a method called map, and a method called filter, and a method called reduce. You know, these are methods that are the same names as the operations from functional programming. It's kind of what everybody's expecting to see. Groovy added these functional features long before Java came along, or before Java added its functional features, and the corresponding methods are called collect, which is really unfortunate because that's kind of a reduce operation in Java. Find all, at least, is intuitive. Find all for filter. In fact, some people don't like filter in Java because filter seems to imply, here, let me show you what I was talking about here. Here's that streams demo in Java. See, here I've got my strings as a stream, and then, oh, I don't have a filter in this? Oh, it figures. At any rate, filter takes a predicate, and the problem is some people look at that filter and go, wait, am I allowing through the ones that pass the filter, or am I preventing the ones that are satisfy the filter? You know what I mean? It's not as obvious. Am I filtering things out or allowing things through? Whereas find all, well, that's pretty clear. I find all the elements such that the following closure is true. Also, they use the keyword inject for reduce, which is an interesting choice, but there it is. Now, if I look at the closures.groovy here, so let me bring that up. In Groovy, you can write a script, and that's what I have here. In this case, the script is basically everything that would be inside a main method, but it is still compiled. I don't want to imply it's not, but notice how I could take the closure syntax and assign it to a variable. Now, one of the things that is true about Groovy is that it's optionally typed. So languages normally are either statically typed, you have to know the data type for everything at compile time, or dynamically typed, where you don't know the data types of anything until runtime. JavaScript, of course, is famously dynamically typed because there's not even a compiler. I mean, everything's done at runtime. But a var reference in JavaScript can be assigned to an integer and then a string and then a function, all in the same program. Among the JVM languages, Clojure, C-L-O-J-U-R-E, which is basically Lisp on the JVM, that's dynamically typed, and they speak very highly of it. Scala, Kotlin, and of course Java itself are all statically typed. Groovy is optionally typed. If I specify a data type here, then Groovy will check that anything I assign to that variable will be of that data type. It will be compatible. Like if I said integer or whatever, I cannot assign a string to it. Or I can use the keyword def, and def says, look, compiler, just don't worry about it. and see what it is at runtime. It's what the Ruby people call duck typing, D-U-C-K, as in if it walks like a duck and it quacks like a duck, it's a duck. So I said def here, but in reality, what I would often do is specify the explicit type, which in this case would be closure. So you can say it if you want, but you don't have to in Groovy. I find that 90-some% of all the Groovy code I write, I put in the static type, or as Dirk Koenig, who is the lead author on Groovy Action, used to say, if I'm coding and I think of a type, I type it, pun intended. You know, if I know what type it's going to be, then I say it, because that makes the code easier to read. It makes the IDEs happy. There's a lot of nice features, but every once in a while, it's really nice to just be able to say def, because I don't care what the data type is, or I don't need to know. It doesn't help me anything to know it. The closure class has a call method, so I can invoke this with 3 and 4 here, but you can also just use the parentheses, and that delegates to call. And also notice I didn't declare data types on X and Y. So this closure works for any class X that has a plus method that takes whatever the type of Y is. And in Groovy, for example, strings work like that. There's a string has a plus method. Again, this is operator overloading. Has a plus method that takes another string and it does concatenation the way you'd expect. But in fact, even in java.time.localDate, they have a plus method that takes an integer and will in fact return a date that's 3 days from now. So Groovy takes advantage of operator overloading to really add a lot of flexibility here. This add is very basically a method that takes any data types as long as the X data type has a plus method that takes the Y data type. We also have a minus method in Groovy in addition to plus, so that in fact this is a method implemented in local date. Groovy has 2 APIs. It has the basic Groovy library, and it has what they call the Groovy JDK. These are methods that have been added to the Java classes to enhance its programming. So they have a minus method in local date that takes another local date and will return the number of days in between. So interesting there. You can even use this ... syntax. That's the vararg syntax. So this says any number of values being supplied, as long as the collection has a sum method, then this will work. So here's add all with integers. Here's add all with a couple of strings. Those are the only classes I can think of that have a sum method. I mean, other floating point values do, but I don't have a completely different one like that. Here, you can specify default arguments in Groovy. I could say Y defaults to 2. So if I say multiply 3 and 4, I get 12. If I say mult with just 3, it'll multiply by 2. So this default argument mechanism simplifies a lot of overloads. You don't need the overloads anymore. Kotlin has something similar. Java does not. I think that's still one of the big missing features of Java that I really miss when I go back, is the ability to declare default values in the method signature, because that would allow us a lot more flexibility and would eliminate a ton of overloaded methods. I have not heard anybody talking about possibly doing that, however. Now, another feature that's in Groovy and is not in either Kotlin or Java is the curry method. What the curry method does is it says, take this lambda, this closure here, and build me a new closure by replacing the first argument with a particular value. So this mult takes 2 arguments. If I curry it with 3, now I have a method I called add 3, and that automatically just takes a Y now and returns 7. And that's currying from the left. There's also currying from the right, where I could put in Y as 2, and then times 2 will take my multiply 1 and multiply by that, or with strings. So Java doesn't have a method like that, but there are kind of ways to fake it. There are ways to build your own if you need to. So this is showing some of the flexibility of Groovy, especially when we say, I don't care about what the data type is, you know, like with these X's and Y's internally. It can be extremely powerful. It's the Spider-Man corollary still applies, though. With great power comes great responsibility. I have to have test cases. I got to make sure. That's what all these asserts are in there, to make sure I did it right. The map filter reduce, again, if I bring that up, so map underscore filter reduce in Groovy looks like this. And again, they have collect for maps. So this takes my list of nums, and this doubles each of them. And then the find all is to say, are any of them divisible by 3? And then sum adds them up. So I'm not using an inject. I'm just actually using a built-in sum method. And notice I didn't have to say what the data types of anything were, because basically this is that duck typing. If the resulting collection has a sum method on it, we're good. And that'll work. So here I can do this with strings. So here I could say, let's map them all to their uppercase and sort them. The false here says produce a new collection. Don't sort the existing collection. Produce a new collection that will sort them by the default sort, which will be alphabetical in this case, and then join them all with a comma. There's my reduction, and here's the result that I get out of that. Or here I could say basically the same thing, but this time they're sorted by the lengths and join it with a comma. And in this case, I just printed the result rather than wrote the assertion here. So if I execute that, you'll see, come on, you can do it. Yeah, there they are by length. So that's 6 characters, and then more, and then most, if you will, without trying to count them, etc. So this is the sort of thing you could do in Groovy with the map, filter, reduce. But again, they use collect and find all, and the reduction methods like inject are available too. And then we already looked at the prime checker. Now in Kotlin, they do things a little differently again. The declared data type goes after the variable in Kotlin. So A here is of type int, and that's a wrapper class, by the way. And B is also an int, and the return type on the function is declared after the signature, before the actual implementation. But the other thing that Kotlin has is this beautiful feature where you see how the entire implementation of this function is a single expression. I'm just returning A plus B. When that's the case, you can reduce the function down to this single expression implementation. You could just use an equal sign for the signature and write the expression, and I don't even need the return keyword because it will be inferred. Whatever this expression returns is the value of the expression, and I also don't need to put in the return type because that also will be inferred from this. Now, some people would prefer to write it this way. Some people write it this way. I'll tell you that if you look at the Kotlin standard library, which I consider to be a nice set of samples of the Kotlin idioms, if you will, they use this mechanism as often as they can. And in fact, there's this subtle pressure to write Kotlin as a series of small, self-contained, single expression functions. And then there's a whole series of methods called scope functions, like also and let and apply, that let you build up these complex single expression functions. So I'll show some examples of that. So the prime number checker in Kotlin looks like this. So here's primes.kt, and I want to show it to you in 2 forms. So let's look at the second one first. Next prime, actually, let's look at this is slightly different than the prime number checker, but it's still doing primes. What the isPrime method is doing here is it says, okay, this is an additional feature, which I didn't mean to get into this right now, but it doesn't hurt anything. Notice how the function here is declaring a data type and then a dot and then isPrime. And this is called an extension function in Kotlin. The idea is that I'm adding an isPrime method to the integer class. So the integer class, of course, doesn't have an isPrime. And in the other examples, I was supplying an int as the argument to isPrime. Here I'm adding an isPrime method to integers. So I'll be able to say like 42.isPrime and get back a true or false on that. And again, I'm doing my single expression implementation. If you're doing an extension function, then the current instance is referred to as this. So there's my this equals 2. And here is a range again. And I was able to do these. Now, this is really different again. One thing you could do in Kotlin that you can't do in the other languages is you could declare what they call top-level functions. You could declare a function in a file by itself, and therefore it's like, well, where's the class? Well, there is no class unless you're trying to call it from Java. That's a different issue. In fact, it's a function that you can import. And there's a ceiling function and a square root function in the Kotlin.math package. Now, I can actually navigate into that. And if I look in the double version, say, you'll see here, this is, if I go to the top, this is a, this is in the Kotlin.math package. I should go beyond the constants. And then each of these functions here is not inside a class at all. And the one I was looking at, actually, let's do it this way again. I'll just navigate to it quickly. See, this is a top level function. And you always use the keyword fun to do this. It's inlined in this case because what this does is it replaces the call to square root with the body, whatever this is. There's my variable, there's my return type, and notice how in the library they're using that single expression syntax a lot. The actual keyword has to do with doing this on multiple platforms. This is the actual implementation on the JVM. There'd be a different implementation on JavaScript and maybe a different one on other platforms as well. But a lot of the library is written so that you can have actual and proposed implementations as well. But notice all these top level functions. Now, as a practical matter, these top level functions are as though we wrote a static function in Java, just without the class. Now, the class, if I wanted to call this from Java, would be the name of this file with KT on the end. Because it's still operating on the JVM, it'll still generate a class, but all these top-level functions will be static functions. That's important because Kotlin doesn't have a static keyword. So they have to handle things differently. They have top-level functions, they have companion objects. That capability, if that sounds familiar to you, is all borrowed from Scala. So if you know that from Scala, that's where they got it. So back to here, what this is doing is saying, okay, if this is 2, great. Otherwise, go from 2 to the ceiling, another one of those functions, of square root of the double. Actually, square root of this is an integer. Square root requires a double or a float. I actually do have to convert it. It won't just automatically convert an int to a double. And that's always takes people by surprise. That throws off Java people. But think of it this way. In Java, we can convert an int to a double without a problem, but we can't just assign an integer reference to a capital D double reference. If you're dealing with the classes, then the assignment doesn't work. And that's what they're implying here, is that int is actually a class. So they have to invoke the toDouble method in order to convert it to a double to go inside the square root method, and then convert the thing back to an int in order to get my range. The corresponding none, the one to the Java one, which was in my prime checker here, the one that was called none match. The corresponding one in Kotlin is just called none, and it takes a lambda, and well, yeah, lambda, and there you see the syntax again, same exact one from before. Now, what's different about Groovy and Kotlin is that these methods like all or every or none have been added to collections directly. See, in Java, they didn't add them to collections. They added them to stream, and they had a way to create a stream. It's the old cliche in computer science where every problem in computer science is solved by adding a layer of indirection, something between me and where I want to go. They said, well, rather than add all these functional methods to collections, we'll add them to stream, and we'll produce a stream from a collection, or many other ways as well. Here, this is actually applying these to a range, which is effectively a list by another name. And Groovy also applies these same methods to collections. In Groovy, if you want to get stream behavior, you just call the .stream method from Java. And now you have a stream and you get stream behavior. In Kotlin, they have a method called sequence. Now, this is generating a sequence this is like an iterator here. And in Kotlin, the sequence behaves exactly as Java streams do. But you can also go directly to the classes and use those. So generate sequence here says, here's the seed, which is num plus 1, and my lambda, and this does the same thing Groovy does, which says it's a 1 argument lambda, and because we didn't give a name to the argument defaults to the word it. And that's the same thing they did in Groovy. So again, that's the lambdas in Kotlin are borrowed directly from Groovy. So this says so this method called next prime says start with the number that was supplied and add 1. And then after that, I'm going to keep invoking this closure here, this lambda, and then I want the first one that satisfies this is prime function that I just added in. Now, this is showing one other feature that, again, is borrowed directly from Groovy. This generates sequence method, if I look at it in the docs, let's see if I can magnify that a little bit. Generate sequence takes two arguments, a seed and a function. See, there's that lambda syntax. T here is a generic type, and any is the Kotlin equivalent of object. So any's at the top of the hierarchy. The question mark means it's nullable. In Kotlin, this is probably Kotlin's biggest selling point in general, is that if you don't put a question mark at the end of a variable name, that variable can never be assigned a null. It will not compile. And if you do put a question mark at the end, therefore making it nullable, you cannot actually access properties or methods on it unless you check that it's not null. So Kotlin really goes to great lengths to eliminate any null pointer exceptions. And if that's something that really matters to you, Kotlin's the language that you'll really like in that way. At any rate, the seed is a nullable argument. And the next function, this is that syntax for a lambda. It's a lambda of one argument of whatever that type T is, and it returns a nullable T again. And this whole thing is returning a sequence. So it says returns a sequence defining by the starting value seed with the function next function, which is invoked over and over again to calculate the next values. So this could be infinite. That's why we need the first method to short circuit out of it. But the other thing I wanted to point out is you see generate sequence takes two arguments. It looks like it only takes one, but that's standard syntax for both Groovy and Kotlin, is that if the last argument on a method is a lambda, you put the lambda after the close parens. So this looks like we've got a lambda hanging out in space, but in fact, it is the second argument on that function. And if I write it this way, oftentimes it'll say, wait a minute, do we want to, here it'll say, put the arguments on, wait a minute. Usually it offers to extract the lambda from outside the parentheses. And in this case, it turned out it didn't ask, but whatever. This would be legal also. So I could write it that way, but more idiomatic in Kotlin and in Groovy would be to go back to the other way of putting the parentheses before the lambda and then having the lambda in space. Likewise, this is the method reference syntax, which is referencing this next prime method right up here. So in Java, we would have written it as this : next prime. In Kotlin, that's inferred. And then we have a take method, which returns the whatever count number of elements. So this is to get the first n primes, and then I can convert it from a sequence back to a list. And there's also a take while this is true and all that. And I actually have a test for this. Where's my test in this? Primes KT. So what package is that's in the functional package? And here's my test. And you may recognize this as a JUnit 5 test. So for example, I made this nice little data class, which I'll talk about in a minute. It combines the number and the expected value. And here I've got this parameterized test that's going to check all the primes less than 20. I'll come back to that. So here, this says, here are my integers. This is pure JUnit 5, where I say, here are my numbers. I want to run them as the argument to this method every time, and I want to assert that they return true and the composites return false. So both of these are standard JUnit 5 tests that just happen to be written in Kotlin. This internal is something that IntelliJ auto-generated. Internal basically means it's scoped to a module. And I don't mean a Java platform module system module. I mean an IDE module. I don't really use it. I usually just delete the keyword internal and I make them public, and that's perfectly fine. But again, these were the test was auto-generated. Notice the back quotes that make it easy to write the statement here for the output. And in fact, if I execute this test, let me just run this particular one. Then again, this is using JUnit 5. You will actually see, oh shoot, I can't, yeah, never mind. I got to run all the tests in order to see them. It's really silly. But you could see that, yeah, I got to play around with the syntax here. Not the syntax, but the IDE is kind of hiding. But you should be able to see all the individual methods. If I ran it through the Gradle build, you'd see, 2 is prime and less than 20, 3 is prime and less than 20. I just have to modify something here in the IDE to show that. I think I'll just go with those for the moment. I don't want to go anything further on that. So, okay, so this stuff is basically showing what Groovy and Kotlin can do that Java can also do. Because I remember I wrote the prime number checker in Java and everything worked. But there's this extra behavior that in Java, streams are what they call lazy. It does not pull any data through the stream unless we have a terminal operation. And when you do have the terminal operation, the elements are processed one by one through the entire pipeline rather than transforming the whole collection each time. So in Groovy and in Kotlin, the collections are as eager as they would be in Java, but Groovy can use Java streams and Kotlin has sequences. So the lazy streams in Groovy, just to show you what I mean by that. What I've done here is I have this, this would be eager. In fact, this says if I want to find the first even number between 100 and 200, that's an open range, that's 100 to 199. I'll map them all to their doubles, and I want to find the first value that's divisible by 3 after that. And these are done on the collection itself, on the range. So this will double all the numbers, and then this will return the first one that's divisible by 3. So there's a lot of wasted calculations going on here. Here, to demonstrate that, I have it verbose, where I could say, let's see the number as we go by, and also let's see the number when it calculates that. Whereas down here, this will use Java streams. I just use the classes from Java, range closed, filter, map, find first, and I'm simply using the Groovy closure syntax where Java is expecting a functional interface. And I have a test case for this just to illustrate it somewhere. Oh, it's the lazy streams test. So let me bring that up. Actually, what package was that in? A streams package. So Groovy streams, here it is. Okay, so this is the spec. So I could do it both in Java and in Groovy. And if I run, for example, the first one, then when this runs, you will see, oh, this isn't the verbose one. Here's the one that's verbose. Actually, this is the Java one. Oh, here, this is a Spock test that'll let me do both. So when this is printed, then the result that comes out of it ought to be 204. And same thing with Groovy, but this will give me the opportunity to do those prints as well. So let me execute both of them. And what you'll see coming out of this is you see all the values are being doubled one by one. Now in Java, we're using a stream, so we're only doing 4 calculations, 100, 101, 102. None of those are divisible by 3. There's the one that's divisible by 3 and then double it. Whereas in Groovy, I'm going and doubling all the numbers here before I get the answer. But down here, I'm just using Java streams in Groovy, and now I'm back to 4 calculations again. Nice and simple there. So if you want to use that behavior, you have it. Now, another feature, by the way, is the Kotlin one, and Kotlin uses sequences for this, which I think I had here. So again, let me magnify this. So this is doing the collections again, where I take, now they use until as a function. This is an infix function. It's a function in between its arguments, but really think of it as 100 dot until with 200 as its argument. But by declaring it infix, I can leave out the dot and the parentheses. So this is that open range again. I map them to their doubles. I filter them by the modulus 3 and get the first one. So this looks like the streaming code in Java, except that this is eager. So I'm doubling them all and filtering them all and finding the first. Whereas if I go down here, by the way, what they're trying to tell me here is you don't have to filter them and then write first. You could put a lambda argument to first and it'll do all together. But here it is using sequences. I call as sequence here. And then when I do the map and the filter in the first, and what you'll see when I run this is just a regular old script with a main method. You see I'm simply going through the values one at a time in this because I did a sequence, whereas the others would be eager. So in Groovy, the methods have been added as extension methods to collections, But you can use sequences if you want from Java. Just write the Java code, which is typical Groovy. In Groovy, if you don't know the Groovy idiom for how to do something, just write the Java code. Chances are it'll work, and then somebody later can show you how to make it, as we say, groovier, you know. Whereas in Kotlin, they had to come up with their own thing, and basically sequences are reproducing streams from Java. And it feels like, wow, they had to go to all this extra work. They couldn't just use Java sequences, or Java streams rather, and not necessarily. They go to great trouble to talk to you about sequences when in fact it's just Java streams with the serial numbers filed off, if you will. Okay, so that's actually this slide as well. So map, filter, reduce. Also, interestingly enough, Kotlin decided not to use the method reduce or the method fold. They used both, which is different. In Java, there's a reduce method, and it takes either one argument or two. If it's one argument, it's a binary operator and returns an optional. You like that? Whereas you'll find a lot of things in Kotlin, by the way, are from other languages with the serial numbers filed off, really. And I don't think the other languages mind. I mean, I think that's fine. They're happy to be, you know, use the same capability. And then, of course, because you can't tell what language you came from, they don't get blamed either. So that's, I guess that's good, you know, if something goes wrong. At any rate, in Kotlin, or rather, I was saying in Java, we have here. Let me show you the where's my browser here? Oops, don't I have a browser open? All right, let me open one up real quick. Yeah, I've got a ton of them, but I moved one out. So here's the Java docs. And in Java, what was I talking about? I was talking about this reduce and fold. So if I go to stream, for example, then in stream, we have a method called reduce. Let me scroll down. And reduce either takes a binary operator, at which point it returns an optional if there were no values left in the stream, or an identity value and a binary operator. And if there's no values in the stream, it just returns the identity, so we get a T back. So this is used for both. In Kotlin, they've decided to call this one reduce, and this one is called fold, interestingly enough. And I have examples of that as well. In Groovy, they used inject for both. So it's the same concept in all three languages, just with different names on a lot of them. So I think it's on my sequence function KT. No, that's not the one I wanted to get into. That gets a little complicated. But I know I have an example where I have a reduce and a, here's a fold, for example. So if I want to add up a bunch of numbers, then here's my list of numbers coming in. Notice how this is a top-level function. And then I'll filter them by the ones divisible by 3 and then map them by doubling them. So it's the same problem I was doing before. But the fold method takes the, now they're calling it initial value, but it really should be the identity operator for this lambda, and this is our binary operator. There's my accumulator, there's every element. Whatever the lambda returns becomes the new value of the accumulator on the next iteration. Now, this is kind of the hard way of solving the problem because, again, I'm doing this eagerly on the list. Down here, if I just convert it to a sequence, then I'll get the answer with far fewer calculations on that. Just be a lot cleaner on that. Okay, now, so here they are in the slides, by the way, just to let you know. There's in Java with my filter, my map, and my reduce, or my filter and map to int, so that now I have an int stream and I can do sum, for example. In Groovy, I've got find all with collect, which is really map. And then this is what the inject looks like, both with an argument. There's also an inject without one. And then this is the sum method as well. And the sum method is using duck typing. In other words, the compiler doesn't say whether or not you can call sum, and if there's a sum method available at runtime, it uses it. And if it's not, then we'll get an error. So that's kind of borrowed concept-wise from the Ruby people, if you will. In Kotlin, there's my map with a fold and the filter, of course, and here's my map with the lambda, just a sum method. In this case, I have to be working with an integer collection or this would not work. Okay. Oh, and then, of course, as sequence, and it's basically a Java stream, if you will. So I have to have a terminal operation like sum or nothing happens. These are considered intermediate operations. They return a new sequence. So If a method returns something other than a sequence, it's terminal operation, and then the data is pulled through. It's exactly the way Java streams work also. All right, I'm going to skip that for a moment. And let me mention this because I'm going to need this for some of the rest of what we're doing. In Java, we have POJOs. And if you actually experiment with the preview features of Java 14, okay, so one of the preview features of Java 14 is called records. And record is a keyword, all lowercase, that will be used where you would normally use the word class. And when you declare a record, then Java will make the class final. You'll provide a constructor for it. That's all you do. And it generates equals and hash code and a builder mechanism and toString and everything. So it's basically generating all the normal stuff that we want on a lot of our data classes. So once we get to Java 14, although again, it's a preview feature, I think it's still going to be a preview feature in 15. Maybe it'll be a final feature in 16. We're still a ways away from that being a regularly used part of the language. In Groovy, I shouldn't have skipped that. Groovy has what they call POGOs, plain old Groovy objects. They have private attributes, public method is a public class, named argument constructors, generated getters and setters. And if you throw this annotation on there, it's called an AST transformation, abstract syntax tree transform. At canonical, it generates toString, equals, hash code, tuple constructors. You get a lot of power from just a handful of attributes and a canonical on it. In Kotlin, actually I have some examples of it. I'm going to skip them for the moment. In Kotlin, it's unfortunate they didn't call them POCOs, right? Plain old Kotlin objects. Now they went with this term data classes. Notice that there's no braces in this. That's the entire class. I can put braces on it and add methods, but if I don't do anything with it, this is the primary constructor. See, I've got name and email, both of type string. When I instantiate a customer, I need to provide both. Val here is basically Kotlin speak for final, so I can't modify them. Kotlin will provide a getter. There's no setter on this one because I used val. But by calling it a data class, I get toString and equals and hash code and a copy constructor and a component method for what they call destructuring. I get a lot of power. Now, this isn't the functional features of the language, but it's often leveraged when you're dealing with functional features in there. So Java eventually will have records. In the meantime, we have Lombok, I guess, to make a data class that way. In Groovy, we can do a POGO with the annotations. In Kotlin, there's a data class to do the same thing. And now I want to show you something going a little bit beyond, and I might take advantage of some of those features. And then I promise when I finish up, there will be cat pictures. So that's coming, right? Just to let you know. So now the stuff I've shown so far has different syntaxes in the different languages, but with the exception of that one little currying example I showed in Groovy, this is all stuff that Java can do. However, there are things that Groovy especially can do that Java cannot, that are real functional features. They get a lot more interesting. Question, any downside to using Kotlin data classes in a Java project? I have not noticed any problem with that. I mean, everything seems to be fine, just like I use Groovy POGOs in a Java project. But more frequently what happens is I use Kotlin POGOs in a Kotlin project and use Java libraries with it. So Kotlin programs tend to use Java through the libraries. Java does do integration with Kotlin as well. In fact, when you want to see a lot of the examples in Kotlin, you go to the Android world because Android's SDK is still Java. And the Android apps are written in Kotlin. So you see examples of Kotlin classes implementing Java interfaces or Kotlin classes extending Java classes. Happens all the time. And it's all bytecodes under the hood. Does it prepend get and set to the property? Records do not, interestingly enough, but POGOs do and data classes do. Although in data classes, actually in both of them, you don't actually call the getter or setter. You access the property as though the property was public, and Groovy will automatically invoke the corresponding getter or setter. And Kotlin, again, it'll look like you're accessing something private when in fact it's a generated. In other words, if I took the bytecodes and I decompiled it to Java, it would be going through the getters and setters there. So it's, you don't necessarily see them, and you can actually explicitly call the getters and setters in Kotlin if you want, but you don't have to. And if you're calling Kotlin from Java, yeah, you'd use the getter and setter methods automatically. So here are some of the things that are more functional features that Java doesn't necessarily have as easily. Kotlin has to some degree, Groovy has a lot of. So for example, closure composition is when you have multiple closures and you build a composite by wiring these things together. Now in Java, they went into classes like consumer or predicate. And here, for example, where's my library? Here's consumer. So this is the consumer interface in Java. And you'll see here, in addition to our single abstract method, they have a method called and then that takes another consumer and it returns a composed consumer that does the current consumer followed by the argument. So we get back a consumer that does the current one followed by the argument here. And this allows us to put two consumers together, if you will. But notice how they had to pick a data type. It's not like they could just combine arbitrary closures. They have to be consumers to work with consumers. Or if I look in predicate, for example, so here in predicate, they have and or and not and negate. You know, these, well, negate's not a composed one, but and or really are. But they had to be declared in the predicate interface. There's no arbitrary way to say, oh yeah, any arbitrary lambda, I want to compose it with another lambda. Java forces you to lock down the methods, if you will, and the classes. And here's an example. I have one called combined lambdas here. So in this case, I have a logger from java.util. And here I'm going to say, for example, here's a null filter. I want to filter out all the values that are null. And here I want a predicate that looks for all the strings who have an even length. And here's a consumer which is using the info method on that logger. And here's a consumer that uses printline to the console. And what I'm able to do now is to take my strings with nulls here, convert it to a stream, and then filter them by this composed predicate. They're not null and they're even length. That'll short circuit too, so that if they are null, I don't evaluate evens. And then for each one, I will log them to the console using the logger and then the printer. And this is as close as Java comes to closure composition. And you can see here, there are the strings of even length being printed out at the console, and here are the logger ones. So the logger always shows up in Java as system.error for some weird reason. That's why this is slightly in red, but they're just info messages. So that's as close as Java comes to closure composition. You kind of have to either use those library ones or write your own for a specific class. Things are a little cleaner in Groovy, of course. So in Groovy, composition here, this uses the right shift operator with lambdas or closures. So this is a closure and I don't specify the type, and this is a closure. So this one will add 3. So this works for any data type that has a plus method that takes an integer. And this works for any data type that has a multiply method that takes an integer. And then the left shift operator or the right shift operator can both be used to make the composed lambda. So this one says do the doubling and then add 3. So if I go times 2, add 3 of 5, it will double it to 10 and add 3. Whereas if I just check it, I could write them individually and see that. Or I could do it with a right shift, but then I have to add parentheses to see that that happens first before the argument's applied. So the syntax looks a little funny, but it's a lot more powerful than what Java has, because you can actually take arbitrary closures and compose, you know, put them together. You can build a whole bunch of closures and then wire them all together like this. Now in Kotlin, we have, again, they don't really have this. You have to kind of write your own. So this monster I took out of the reference docs for Kotlin. This is a function with 3 generic types, A, B, and C. Notice they use the same generic type syntax as Java. So the compose function that they're building takes a function that maps from B to C. See, there's a lambda expression, and another lambda that maps from A type to B type. and it's ultimately going to return a map from A to C. And how are they going to do it? Well, they're going to take the f function and apply it to the g function applied to the variable. Wow, that's quite a mouthful. So whatever the argument is, they'll apply g and then apply f to the result. So here is a length function on string where I just access the length property. Here is an is_odd function that takes an integer and returns a Boolean. Just see if it's mod 2. So now I can compose is_odd with length and get an odd length function that maps a string to a Boolean. See, is_odd maps an int to a Boolean. Length maps a string to an int. So I can compose those together and go from a Boolean, from a string to a Boolean. And there's an example where I made a list of strings and I filtered them by odd length and then also printed them. There's one of those scope functions that allows you to chain onto a single call. So you see, this is kind of contrived. This is not built into the language. They had to build it themselves. So do they have closure composition? Sort of. They don't have a special operator like Groovy does. They don't have an easy way to do it, but you can write your own in a far more generalized way than you could do it in Java, where you've got to pick the actual data types, the actual functional interface that we're working with in each of those cases. All right, so I think that shows that Kotlin is young. You know, Groovy's been around for 15, 16, 17 years. They've had time to build up features like this. Kotlin is still developing. I bet by the time Kotlin is in version 2 or 3, they'll have something similar as well, but right now they don't. Now, tail recursion is another neat mechanism that works in Groovy and in Kotlin. Java doesn't have anything like this. Now, Kotlin added a keyword called tailrec, and I'll show you an example in a minute. Whereas in Groovy, they used what they call an AST transformation, abstract syntax tree transformation. Canonical is another one. What an AST transform does is it says, hey, compiler, during the compilation process, this annotation tells me to modify the syntax tree, however it's specified in the annotation. And it will implement tail recursion for you in the syntax tree. All I have to do is annotate the method, a recursive method that would normally overflow the stack. I'll annotate it with tail recursive, and suddenly it gets the iterative behavior from tail recursion. In Java, or Kotlin rather, they added a keyword. So if they want to do more broad things, they're going to have to add more keywords to do it. Whereas Java doesn't have tail recursion at all. You can write the function, but it won't reuse the stack frames, as they say. And to show you that, I think it's in annotated functions in Groovy. So let me see if I have that one. Yeah, there's a couple capabilities here. Here's the tail recursive one of computing factorial. So I say, let's start with a big integer n. And then the second argument will be the accumulator, and 1g is for the big integer type. And the rule for tail recursion is that the last call in your implementation must be the recursive call. So here I want to call factorial again with new arguments. So how am I doing tail recursion for factorial? Well, if n is less than 2, then return the accumulated value. So if n is 1, then if actually what I'm saying here is the factorial of 0 and the factorial of 1 is 1. What about the factorial of 2? Well, we'll call factorial of n minus 1, and then this will modify the accumulator, n times the accumulator. And by saying tail recursive here, this will in fact reuse the stack frames on the recursion, and thereby I can invoke this method on very high values. So this tail recursion one here, actually, where was the factorial is the one I want to look at. And if I have, where's my factorial one? So here's factorial with the recursion. I only did it for up to 8 here, but in fact, I can use it for extremely high numbers. Here is tail recursion on sum, and I could sum up 1,000,000 numbers with this, you know, and I've got the functions in here and everything. This is the sum up with tail recursion again. I have a number and a sum. Notice how convenient the default arguments are. I can just call sum up with a number. It'll assume sum is 0. And then if the number is 0, return the sum. Otherwise, do sum up of n minus 1 and then add the two together. And tail recursive will reuse the stack frames. You saw I was able to do that in the millions without having a problem. Another capability that Groovy has is this annotation called memoized. It looks like memorized, like they missed a letter. But the idea behind memoize works with pure functions. So remember, a function that only has the same output for the same input. So it's not dependent on anything else and has no side effects. And what memoize will do is it will internally make a map of calls of given numbers, and the values will be the result. So in other words, the first time I run fib of 10, it might take a little while to compute it. But the second time I run fib of 10, it just gives me the looked up answer because it's maintaining this map internally of previous calls. See, this is a classic example of a recursive implementation of Fibonacci numbers that is almost guaranteed to overflow very quickly because, again, fib of 10 will call fib of 9 and fib of 8, and fib of 9 will call 8 and 7, and fib of 8 will call 7 and 6. So you get this combinatorial explosion in the number of fib calls because so many are repeated. Well, by throwing on an @memoized, this works just fine because as soon as it's computed fib of 2, that's in the map. And then fib of 3 is in the map, at 4, at 5. And once again, I can go to extremely high numbers and not run into an overflow. And this is an AST transformation that generates all that. Here's the one on factorial, same thing we were doing. Again, if n is less than 2, return 1. Otherwise, just write it this way. And I have a test where I threw in a sleep just to demonstrate that the first time I call it, it takes a second to run. The second time it's just in a lookup table. Now there's the tail recursive examples. And then in Kotlin, I know I have it in Kotlin as well. So this is the Kotlin functional algorithms here. Yeah, see this factorial one right here. This, again, is taking advantage of the default arguments. So I have a long that I want to compute the factorial of, and this will be the accumulator, which I'll initialize to big integers 1. So I don't need to provide that. So in my test, for example, so my factorial tests, where's the factorial one? Yeah, look, I can compute numbers like this, like factorial 75,000, and get a value where, in fact, I didn't even get the value. I just said, what's the length of the resulting number? And it has 333,061 digits in it. Now, I disabled this one because it's slow, but it does pass, in fact. Now, what this looks like, again, in Kotlin is I have the tail rec method, or tail rec keyword on there, so that this will reuse the previous stack frames. Because this is tail recursion, the last call has to be the call to the same function again. So this says, all right, here's n, and there's big integer 1. And when n is 0, return 1. If n is 1, return the accumulator. Else, call factorial with n minus 1 and multiply the accumulator times big integer wrapped around the value of n, and this just gets called on any given size, and it just gets bigger and bigger. Now, an alternative to doing this is I could have done a fold here, which basically is transforming my recursive into iterative. So iterative doesn't overflow. But here I can actually do the recursive call and not overflow because the tail rec keyword will take advantage of all those stack frames and I can use them again. The other cool thing here is this annotation JVM overloads. You see, in Kotlin, we have default arguments. In Java, we don't. So if I wanted to call this method from Java, it would think it would take 2 arguments. So I'd have to supply something for that second argument. By annotating it with JVM overloads, I will get 2 overloads. I'll get the one that takes 2 arguments and the one that takes 1 argument in the bytecodes, and therefore Java can invoke it with just the long here. So the JVM overloads annotation was designed exactly for Java integration to make things like these overloads work. So in Java, it'd be 2 separate methods that take 1 argument or 2. In Kotlin, it's just 1 like that. And it's a nice integration mechanism. Okay, now Kotlin does have this library that everybody talks about for going into much more pure functional programming. That library is called Arrow. It's still under development, but that's when you get terms like functors and what am I thinking of? I'm sure somebody knows exactly what I'm thinking of. The it's the concept where if you know how to explain it, you can't do it, and vice versa, or something like that. Monoids. Yeah, monoids, right. So they have monoids and monads actually is the one I was thinking of, was monads. So the Kotlin library does that. Java will never really have monads because they don't have a good way to deal with nulls. There's no way in Java to prevent nulls. There's annotations, but they're not part of the standard library, and even there it's not clear that you can do those on properties, but not necessarily in methods. So there's always issues in Java. Groovy is resting on top of Java. They may be able to make monads, but it's really not easy. Kotlin gets rid of nulls. There's ways to enforce that, and therefore the arrow library will allow you to actually get into that stuff. Question, why wouldn't Kotlin automatically just make the overloaded functions available for Java to use? Because there's no need. I mean, why generate the extra function if I'm not calling it from Java? If I'm just doing pure Kotlin on both ends, why make the extra one? At least now, okay, I'm not on the core team. I don't know the reason, but that's what I'm guessing it is. I'm guessing they figure if they don't need it, why say it? Okay, but you can make the argument, I guess. Now, a little bit about metaprogramming, and that'll lead me to my big cat pictures demo. So Groovy has the ability, I already mentioned the AST transformations, but you can do compiled runtime metaprogramming in Groovy, and it looks like this. So this says, I'm going to go to the string class, and I'm going to get its meta class. And in Groovy, every class has a meta class, and the meta class allows you to add new properties and new methods to the class at runtime. So I'm adding a method called pirate, which will be a 0 argument closure. That's what this is. See, the arrow here with nothing to the left of it means I specifically want 0 arguments. And I'm going to read my key in. I've got the file class called pirate key, and .text will retrieve the key out of that. And then I'm going to this RESTful web service. And, I hope you like this because I paid $5 for this month so I could run this demo on this. And this is the URL I'm going to access, but now I need to supply the query string on it. So I'm going to convert this to pirate speak. So what I'm going to do is make my query string by saying the text is encode the delegate, the string that I am invoking .pirate on under UTF-8. Now, URL encoder .encode, that's pure Java. So in Groovy, again, you can use the Java library to do whatever you want. Then add in the API key. This is the overall URL. That's the string. Notice the double quoted string with the $sign that it interpolates values inside it. Kotlin has the same syntax, by the way. ToURL is a method that's been added to the string class to convert it to an instance of java.net.url. So that parses a URL out of it. And then this invokes the getText method, which will go to that URL and download the JSON data from the RESTful web service. Groovy has a class in it called JSON Slurper, believe it or not. And this has a parse text method. So this downloads the JSON data, and then I parse it, and I know from the structure of the JSON data, I want to go to the contents child and then the translated grandchild. This is one of those cases where def makes sense because I don't even know what the data type is. It's some JSON type, some JavaScript object notation type, and it's just there to be navigated. So if I knew the actual class, it wouldn't help me any because the IDE doesn't know the structure of the JSON stuff. In fact, that's what this is saying is, I don't know what you mean by contents on this. I hope it's there at runtime. And again, I'm just navigating the tree. So this adds the pirate method at runtime to any string. So here are my print lines of hello world, or how are you today, or please fill out your session evals, or the dreaded, I'd like to add you to my professional network on LinkedIn. So if I run this, you'll see, ahoy world, how be ye today? Fill out your session evals. I'd like to add ye to me professional network on LinkedIn. I mean, you say what you want about the translations, but the cool part is I've added a pirate method to string, which is pretty cool. Is that like an implicit in Scala? I honestly don't know. I know only the hello world level of stuff in Scala. I don't know enough about Scala to be sure. I'd have to ask my friend Danny, who hosts my Scala reference, so I don't know the answer to that, unfortunately. Now in Kotlin, we do extension functions, and I already showed you the primes one. Here is an alternative extension function for computing palindromes. So the idea here is I have an isPal method that takes a string, and this code right here, I would call this speaking Kotlin with a Java accent, okay? Because this is how a Java developer would write Kotlin. They'd say, oh, I have a method that takes a string, and I'll convert it to lowercase, and then there's a replace method to replace any series of non-word characters as a regular expression with an empty string. So this replace method is to get rid of the punctuation. And then I'll test the string against its reverse value. I am taking advantage of the Kotlin libraries to make this is called a raw string, so I don't have to escape the escapes. And it has a method to convert to a regular expression. And here I am using the operator overloading. But here is probably what I would argue is more idiomatic Kotlin. I'm adding is palindrome to string at compile time, by the way. I convert it to lowercase, I replace the regex with empty string, and then this is another one of those scope functions. It basically says, after we're done with the replace, let's do whatever's in this block. See, I could just chain this condition onto the previous method by simply saying let this block, it equals it dot reverse. So instead of having to create a temporary variable and then write the return statement with it, I could just chain it on due to that scope function. And if I look at my palindrome tests, figures it's not written directly in there. I had it. Here's my tests here. And you can see I'll be able to do for the extension function, Madam and Eden, I'm Adam, or Flee to Me, Remote Elf. There's your Lord of the Rings palindrome. Or how about this one? A Santa pets rats as Pat taps a star step at NASA. My favorite is this monster. This thing is 543 words long. You know, all ending in Panama, you know, a canal, Panama, all the way at the end. But in fact, it's 43 words wrong. I trim the indents and then check that it's a palindrome, and notice the multi-line string syntax. That's another syntax that Java's adding, which I think went final in 14. So it's going to be a while, but eventually we'll be able to do that. I also have my is not a palindrome just to make sure. And this is the one where I'm calling the function instead of doing the extension function. Pretty much the same thing, just to make sure they all work. And if I just execute these tests, then you'll see those will pass as well. And yeah, now things are running at the speed I was expecting. So they're all working on that. So that's the idea of an extension function in Kotlin. And Groovy has both the AST transforms at compile time and the meta class for runtime metaprogramming as well. Okay, last demo I want to show you is about cat pictures. Now I have to give a little bit of explanation of this. Here's the URL I'm going to access. So let me copy this and open it up in my browser here. This is from Flickr. This is from Flickr's API. And as you may know, Flickr was several years ago bought by Yahoo and then left to die. You know how it is. And I actually had to register and get a key at Yahoo. So I'm going to inflict this demo on people because that was painful. Flickr has a RESTful web service for searching for photos. And the way it works is that if I invoke the method, it's called Flickr Photo Search, that I need the API key. Everything else is optional. And what it will return, if I go to the bottom here, actually doesn't show it right here. So I'll bring it up here, is that you get back JSON data inside there. And let me show you a program that uses both Groovy and Java together to get a bunch of cat pictures downloaded in parallel, no less, using parallel streams, and then rendering them using a Swing builder. So here's that application. This is, actually, let me just look for it, catpictures.groovy. And I'll show you this. So I got a bunch of import statements. Notice, by the way, in Groovy, you can do aliased imports. So I can just refer to window constants as WC, by the way, inside here. But this is the endpoint. There's my Flickr REST endpoint. And this is a map of parameters. So key, colon, value, key, colon, value. I just format it this way, make them easier to see. Notice they're all separated by commas. So I'm going to invoke the Flickr photo search as the method. The key is again in a text file. I want JSON data back. Now this is going to be the dicey one, because here's I got to warn you, I don't know what I'm going to get. okay? Because I'm going to get whatever the last 6 photos are at Flickr tagged with the word cats. And I've gotten dogs, I've gotten monkeys. Every once in a while, I get something completely inappropriate. If that happens, I'll just close it and change the keyword to something that worked better. But I'm not 100% sure. So if you're waiting to watch me embarrass myself, this is the time it's going to happen. I only want photos, and I want 6 of them. Oh, did somebody get 3 dogs on that? Okay. So at any rate, let's see how this works. The map here, which I called params, I could do a collect to return it. And what this does is the toString method on map.entry is key equals value. So this will transform the map into a collection of key equals value ones and then join them with an ampersand. So the full URL is the endpoint and then the query string .toURL.text. So there, now I've downloaded my JSON data. I'll write it to a file so we could see it. So I could always go and look at the JSON data. I'm also going to print it to the console. So even if the images don't work, we can see the JSON data. Then I use the JSON slurper to parse it and extract the photo element as a grandchild of the root. So there's a root and then there's photos. And then inside photos, there's a photo element. And the way Flickr works is that the photo element has a farm and a server and an ID and a secret property and a title, by the way. But these properties are used to create the overall URL for the images itself. So here what I'm going to do is I have this method I called photo to image. So take the photo, print out which thread I'm on and the title, build the URL, and then I'm going to read the data from that URL. And then what I'll do here is right now I'm going to do this in sequence. Just map all of the photo elements to images, collect them into a list, and then this is a swing builder. On the event dispatch thread, make a frame that will close at the end, put my images in a grid layout, and for each image, take the image, put it in an image icon, which goes inside a JLabel. Okay, keep your fingers crossed. And it should, there's the JSON data, and let's see if I got cats. I got 3 dogs, but actually it's the person logged in as Fly told me that. But no, there's cats in there too. Hey, I'm declaring victory on that one. I mean, I tell you, I've gotten some strange pictures at Flickr, but there they are, came right out. Now, because I know those are the pictures, let me go back here and change stream to parallel stream. Now, this is not a good idea. Now, I mean, because yeah, okay, it'll use a fork join pool and it'll download them all simultaneously. The problem is I only have 6 pictures. It's really fast to do 6 queries sequentially. So by doing this in parallel, I am going to add a lot of overhead and then have each processor on my disk downloading a cat picture and then join them all together. And frankly, that overhead is going to take more time than the basic query did, than the sequence one. But just to show you what's possible, here I am, got my pictures again. There they are, cat, 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 and cat. And that worked out. And you see the titles I printed out as I went along. And in fact, notice the threads I'm on. I'm on the common pool with these various worker threads. And the main method. So it actually creates a fork join pool of the size of the number of processors you have -1, but main is also running. So I have enough processors to do them all. Now, I'm not going to try to access YouTube. I'm a little nervous about that. But this, hey, it worked, and I'm just very pleased. And notice how I'm using Groovy and Java together. I couldn't figure out a way to get Kotlin in there, too, so I'm just going to go with that. So, okay, let's summarize everything. You can use all on the same project, and the recommendation is use each for what it does well. Java is really good for tools and libraries like Spring and everything, and basic infrastructure. I mean, Java is quite mature, very effective, optimized. You know, it's very powerful. And then I use Groovy for anything that goes beyond that, and Kotlin if I still want to retain null safety and some functional capability, but not as much as Groovy has if you want. And then you're welcome to mix and match. So Java has functional capabilities, our streams, our lambdas, our method references, but Groovy goes way beyond that and it's quite mature. Some people aren't so wild about some of the metaprogramming stuff, but Groovy also has traits. Those are interfaces with methods that have a body, similar to default methods in Java. It has a whole rich family of AST transformations. One called, for example, compile static, which will remove all the dynamic features and optimize the bytecodes for speed. There's an add immutable AST transform. But Kotlin has a lot, just not as much as Groovy has. And again, I mostly attributed to that, to the fact that Kotlin is by far the youngest of these three languages. I think it only went 1.0, maybe 3 or 4 years ago at this point. And that's basically it. So all the code is in that GitHub repo. I will update that if necessary. Here again is my contact information. If you need to access me, again, I got the newsletter. It's, I say I'm an old white male. Of course I have a newsletter, but at least it's free. And these are the books and everything if you're interested. So are there any questions, comments, words of wisdom, heard any good jokes lately? Feel free and I'll be happy to address them in there. Oh, thank you. Appreciate that. So hopefully you'll like that, and all the code is in there, and they're all using the most recent release versions of the languages in there. Oh, thanks.
Okay, there we go.
Mm-hmm.
Yeah. All right. It took some time. Apparently, the mouse clicked faster than what Crowdcast was looking for. Star Trek Lower Deck jokes.
Yeah, well, there's a new episode out today, right? My wife's probably waiting for me to go watch that. They're coming on Thursdays. I really am enjoying it. I know that some of the critics don't like it, but I think they're a riot. So
very good. All right, so we will go over here we go, the door prize drawings. Yeah. Oh, and I said, yeah, well, whatever. Anyway, so for our JetBrains licenses, this is going out to Abuzzer and Peng. We've got your email addresses, and we will ship those out to you. And Jim, I have your email address for the Agile Learner, and you'll get that. Should be after this. If you don't get it by tomorrow, let me know. And then last but certainly not least, Brian, Kate has your email. She'll be reaching out to you to ship or in some other way get you those cookies. So without keeping you guys any longer, there's that. Again, here's what's coming up. So next month you've got Nate Shuda, which Ken was saying is a very good talk. You won't want to miss that. And of course, Edson Yanaga, Reactive and Quarkus. If you've been looking at Reactive or Quarkus or either of those two things, or just want to hear Edson talk, he's a great speaker. You won't want to miss that one. And then, of course, Baruch talking about DevOps patterns and anti-patterns. So we've got some great lineup for the rest of this year. We're really looking forward to it. And I think that should clear everything up. So once again, thank you, Ken, for coming out. And thanks everyone for attending. If you enjoyed tonight, please tell your friends. We are definitely lower than what we typically have been when we're in person. I don't know what to attribute that to, but we'd like to see our numbers come back up. And if you scroll back up to the top, there is our YouTube link. We need 100 subscribers. I was off. We're currently at about 39 or so. So if we can get some more subscribers, we'll get a vanity URL and it'll be easier to find us. But you can find this talk and other talks that we've done during COVID here on Crowdcast, and then also up on YouTube. So thanks again, everyone. Appreciate you coming out, and we look forward to seeing you again next month. Thank you all.
Take care. Thank you very much.